Okay, it's time to change. And now Howard.
Okay, now for something completely different. I promise I won't be talking about swimming pools, or at least not too much. You may be curious about this first slide. I'll try and explain it. About 4 weeks ago in Germany, there was a report which almost went unnoticed. It was that 75% of all flying insects are gone. That's over the last 30 years. Now, partially due to the reduction in habitat, but mainly due to pesticides and chemicals in the environment. The significance of that is if we lose 90% of all flying insects, then agriculture collapses. Really important. This small organism is called a copepod. It's like the insects of the sea. We lose these copepods, we lose the marine environment, and the terrestrial ecosystem will collapse. So I've got 30 minutes to explain how that could happen. Now this slide is titled What We Do. I think it'd be better titled Our Mission, because everything is connected with AFM, with the swimming pools, with the project we did in Bangladesh, with the provision of clean, safe drinking water. And Dominic and Philip were absolutely correct. The swimming pool water is actually much better than drinking water. The reason for that is that 86% of all the drinking water now in Europe contains microplastics. It's the same all over the world. And the microplastics absorb chemicals to a very high level, toxic chemicals, and we're all ingesting them. So monitoring the oceans, monitoring the environment is critical for the well-being of everything on this planet. And AFM, the mission and objective of AFM is not just in swimming pools, it's the protection of our aquatic ecosystem, and that includes the rivers and the sea. So I want to try and cover 4 topics over the next 30 minutes. Marine biodiversity. Okay, I'll try it. It'll be difficult. I'll briefly talk about the project in Bangladesh, the textiles. Also, another mission that we're on is the provision of clean, safe water for the developing world. And then we'll finish off with the activation of AFM. But first of all, the environment. Billions of tons of waste go into the environment every year. Many of them are plastics, and the plastics break down into microplastics, and that's really quite a dangerous situation, which I don't have time to explain with this, but it is very, very dangerous. We have got discharges from all different sources, from municipal wastewater, from industrial wastewater, river pollution. This is a textile town in China. About 20% of the industry in China is textiles. Bangladesh, where we're working, 80% of the industry is textiles. And in and around Dhaka, 100% of all surface water is destroyed. 90% of all the groundwater is destroyed. They're going to run out of water. 22 million people running out of water in 3 years. So a pipeline is currently being built from Dhaka to the north of the country because of environmental pollution. You do not have a sustainable economy if you do not have a sustainable environment. So absolutely critical. But pollution comes from all different sources. Atmospheric pollution. But the common denominator is that it all ends up in the oceans. Everything that we discharge eventually ends up in the sea. What you're probably not aware about is, we hear about climate change and the increase in CO2, but oxygen levels are dropping. And indeed, they're dropping at a rate 2 to 4 times higher than the CO2 levels are increasing. Now, if this was due to climate change and the burning of fossil fuels, it would be in equilibrium, it would be a stoichiometric relationship. It's not. They're dropping 4 times faster. If we look at CO2, the oceans absorb about 30% of the carbon dioxide emitted from the burning of fossil fuels. About 60% of the CO2 is absorbed by mineral erosion on silicates, and about 10% of the CO2 is absorbed by plants. Now, you could actually cut down every tree in the planet, rip up all the grass. It will make no difference to CO2. The only terrestrial ecosystem that's absorbing CO2 are peat bogs and marshland. And by way of example, if you take the peat bogs in Scotland and Ireland, combine them together, they actually absorb more CO2 than the Amazon rainforest. So 2 small ecosystems absorbing more CO2 than the whole of Brazil. In a recent report from NASA, satellite imagery, they're reporting that primary productivity in the oceans is dropping by 1% year on year. Now, if 80% of our oxygen comes from the oceans and it's dropping at a rate of 1% a year, that means that 0.8% of the planet's plants are dying every year. This is not sustainable. Another report published in Nature reported that primary productivity, that's the algae and the bacteria, has dropped by 40% since the 1950s. Now, we're pumping CO2 into the atmosphere, we're discharging municipal wastewater, lots of phosphates, lots of nutrients. Almost every report states that the reduction in productivity, the change in biodiversity, is due to climate change. But if you're pumping CO2 into the atmosphere and into the water, as well as adding nutrients, phosphates and ammonium, it should have increased. We should be seeing massive blooms of algae and bacteria. But we're not. It's going down. And it's going down at an alarming rate. Now, whenever you have CO2 in the atmosphere, a proportion will dissolve into the water, and it forms carbonic acid. Now, the CO2 should be metabolized by the algae and by the bacteria. If it was, then the CO2 levels would not be dropping. This graph shows some historical data with regards to CO2. Currently, the oceans are sitting at a pH of about 8.06. 40, 50 years ago, it was 8.2. If you take the IPCC data and take it forward, this is on the basis that there'll be a temperature change of 1.4 degrees C. And considering that China will not stop reducing CO2 emissions until 2030, India is doubling and trebling, then RCP 8.5 is very likely. And if you extrapolate that forward, then by 2050, oceanic pH will be 7.9, 7.95. Now in Dryden Aqua, I'm a marine biologist and Michael's a marine biologist. You know, we're involved in the life support systems for many of the world's big aquaria. And we know for sure that if the pH of the oceans drops to 7.9, 7.95, then it's impossible to culture fish, certain invertebrates. And what we're potentially looking at here is a cascade failure, a trophic cascade failure of the marine ecosystem. And that's not good news, because if we lose the marine ecosystem, the terrestrial ecosystem will also collapse. So this statement, when we're gone from the oceans, we're taking 2 billion of you with us, we believe is correct. Because if we lose the marine ecosystem, then we also lose all the fish, all the birds, all the whales. Everything is gone. What we could be left with will be jellyfish and squid. There might be other deviations to that, and I might be making sweeping statements here, but I cannot pick any holes in this, And I've asked so many marine scientists, and none of them can pick any holes in what I'm saying. It's not all doom and gloom, although this slide is. This is an orca, killer whale, washed up in a beach in Europe. Levels of PCBs 5 times higher than the concentration that would cause serious damage to the animal. I think last year 5 or 6 sperm whale were also washed up, full of PCBs and organic tin. So, perhaps climate change is not directly due to CO2. Obviously, CO2 is very important and it is responsible for the greenhouse effect. The amount of CO2 being pumped into the atmosphere every year is about 3.75% of all the CO2 going into the atmosphere. But if the oceans are taking out 30%, and we've lost 40% of that ability, then if we hadn't seen that reduction in primary productivity, we would not have climate change. So the potential solution here is, of course, to try and reduce the amount of CO2 being produced. But it's to try and take the brakes off the system by the elimination of toxic priority chemicals. It's like chemicals in the carpet, fire retardants, PBDE, PCBs, organic tin. Europe manufactures 200,000 tons every year of chemicals that are deemed to be too toxic to have in the environment. Yet we make 200,000 tons. We make 30,000 tons of organic tin, TBT, DBT. These are the plasticizers that are in plastic. If you were to take 1,000 tons of organic tin and dissolve it in the oceans all at the one time, you would kill all life in the oceans. Yet we're dumping millions of tons of plastics into the oceans. But as I said, there is hope. If we can reverse the state by reduction of priority chemicals, namely PCBs, PBDE, organic tin, methyl mercury, then we take the brakes off the ecosystem and we allow marine algae to start growing again. They only take maybe a few hours or a day or so to grow. Bacteria take about 15 minutes to grow. So if we remove these chemicals from the ecosystem, the recovery is going to be very quick. Equally, if we don't do that, then the oceans can potentially crash, and that will also be very quick. Now, we estimate that we have 25 to maybe 40 years before this happens, and when it starts to go, it will go quick. We're looking at perhaps 2 or 3 years for that cascade reaction to go right through the ecosystem. But over the next 10 years, if we can affect change, then we have an opportunity to reverse the situation. So it's kind of important. And that really is the mission of Dryden Aqua. And it's no exaggeration when we want to try and save the planet. It might be a bit presumptuous and ridiculous for an SME company from Scotland and Switzerland to do this. But when you're aware of the potential that could happen, then it's our ethical obligation to try and do it. Now, one of the projects that's already been talked about is the textile industry in Bangladesh. Textile industry is responsible for 10% of all the industrial pollution going into the environment. It's the second biggest polluter in the world after petrochemicals. It's also responsible for absorbing discharging 5% of the CO2. Now, every textile company will have a water treatment system, but I've been around about 20 or 30 in Dhaka, and I can say that not one of them was working. They might have the equipment in place. Some of the systems are actually very good. but none of them were actually working properly. Now, you have to understand the environment and the culture to appreciate what is actually going on. There's no point going in there with ozone systems and reverse osmosis. It doesn't work. It's too expensive, it can't be maintained, you have a failure, the equipment then is just lying there. So, what we endeavoured to do was to understand the requirements, understand the process, and then develop a sustainable option for the industry. And we've done this. We designed it, we built it, and we commissioned it. There's a short video on what we've done. Sorry for the Star Wars introduction here. What we have done here is we've re-engineered how an activated sludge plant operates. See, most wastewater treatment systems are designed and built by engineers, but it's a biological process. And we understand what the bacteria require, from the environment and from the systems, and we've tuned this system into dealing with the dyes. And then using AFM for the tertiary treatment. So, really, for the very first time, we now have a sustainable textile wastewater treatment system. And if this was applied to all the textile companies throughout the world, we would reduce the pollution load by 10%. So this is really a demonstration of what you can do. And we're debating whether or not to open source, this design. And in fact, we may well make that decision towards the end of next year, once we're absolutely happy we have every parameter correct. And if we do that, we also reduce the world's CO2 burden by 5%. So it's quite major. In fact, very major. The other area where we're working, and I spent 5 years in West Bengal, a remote village about 250 kilometers north of Kolkata. And what we were looking at was drinking water treatment, because in India, Bangladesh, Africa, and indeed many developing countries, 80% of all disease is from the consumption of drinking water. And in this day and age, that is not acceptable. Again, in my travels around India, there are many rural community drinking water systems. It's not difficult to treat the water, but what has been very difficult is to do it in a sustainable, repeatable fashion that the communities can manage and look after. Usually when I go into a village and there's a rural community system, within 1 year, maybe 2 years, it's not working, can't be repaired, can't be fixed. Average income is $2 a day. How are they going to afford to buy a valve at 100 euros? It's just not going to happen. Which is tragic, because in West Bengal and Bangladesh, the water supply is mainly groundwater, contains 250, 300 micrograms of arsenic. It's natural arsenic, this is not pollution. But levels as low as 20 micrograms will cause neurological damage to children. Yet they're faced to drink water containing 200 micrograms. Water source, surface water. If you drink water at the Ganga, or ponds that are used to collect water during the monsoon season, then you are going to be consuming copepods. Again, it's a freshwater copepod, but it can carry cholera. Even though you chlorinate the water, you would not kill the Vibrio cholera bacteria that actually lives inside the copepod. On average, every person will get 2 or 3 episodes of cryptosporidiosis. And this is hugely damaging to their health and well-being, to the societies and to their economy. This is a real photograph, before and after, AFM. So we're able to take water out the ground and treat it using a Calplast filter in AFM and provide water with levels of arsenic below 10 parts per billion. We can take water at the Ganga. There's a bit of pre-treatment required, but we can provide drinking water from almost any source. The problem is that when you have an automatic valve or a control panel, it's going to fail and it will never get fixed, or they can't afford to fix it. So what we've done is we've developed a new type of sand filter, one which is manufactured from a polyethylene pipe. It's a completely automatic filter, no valves, no control systems, runs off solar power. We think it will run for 30 years without any attention. So we've also initiated a new company called Clean Water Wave. We want this to be a tidal wave going through the developing world. And it's a social enterprise company. It's a not-for-profit or not for personal profit company. All the profits that the company make will go back in to buying more water treatment systems and developing sustainable social enterprises within the communities. So we've just started this. We have a lot of work to do, but we plan to put the first systems into Bangladesh, into India, Africa, and we have 3 going into South America. So over the next 6 months, we'll be working on this to roll out the CAFE filter. It's called CAFE because it's Clean Aqua Forever. AFM will last for 30 years. The filter, we reckon, should last for 30 years as well.